Okay, in this next lecture, we're going to finally get to the third effect that we often talk about statistically, which is something called an interaction. And the way I want to get into an interaction is I actually chose this example with pills and beer because it's one of those situations where we know in the real world we shouldn't be taking alcohol and barbiturates or benzodiazepines at the same time, and the reason for that is because we know there's a drug interaction. Now think about what that term means, a drug interaction. If you think about it, it basically means that it's okay to take one drug at a time, but if there's a drug interaction, when you take a second product, the second product really escalates and enhances the effect of the first drug. So there's a drug interaction when one drug interacts with another one. Biochemically, we actually know that alcohol and Xanax basically work at the same receptors in the brain. So if you take both of them, they enhance each other in such a way that it really becomes a problem. And so in this situation, look what happened to motor performance here. In the motor performance, when you only had a little bit of alcohol, what happened? You went down by 20. When you only had a little bit of pills, what happened? You went down by 20. But when you combine the alcohol and the pills, what happened to performance? Did it just decrease by 20 and 20 and 40? No. When you combine the pills and the alcohol, performance went down by what? 80 points. And so in this case, there's what's called a drug interaction. The effects of one drug enhance the effects of the other drug. And this can be very, very dangerous when you're mixing medications, psychiatric medications. The reason I shared this psychiatric example with you is because this actually is mapping very well to our thing called a statistical interaction. You know you have a statistical interaction when, in this case, the levels for 72 ounces of alcohol and 50 levels of Xanax are enhancing each other here. So the way we actually figure out statistically if there's an interaction is we make a graph. And if you look at the graph that I made down here with the Xanax and the no Xanax and the alcohol, the way you know there's an interaction is if the lines are non-parallel. So take a look at that. The blue line goes 100 to 80. That's the no Xanax group. But look what happens to the other line. The other line, starting with Xanax and no beer, starts out at 80. But look what happens when you combine the Xanax with the alcohol. Goes all the way down to 20. Those lines are very non-parallel. And so in this case, we would have what's called a statistical interaction as well. So when you put all those numbers into the computer, it would probably show that very effect. So with that being stated, and I hope that makes sense for you, let me stop this. Actually, let me go into one more screen here. The next screen is a very optional screen. I actually just wanted to show you if you ever need to input a two-factor ANOVA into SPSS, this is how you would actually input this data set. One column would be the DV with all the numbers there, and then the second column might be alcohol. You wouldn't put the linguistic words beer and no beer. You'd actually put ones and twos and then make little labels out of it. And then with pills it would be the same thing, ones and twos as well, to basically label the matrix. If you ever need any help on doing any of this, let me know. If you've already done this, that's great. If you don't know what I'm talking about, that's fine as well. So this will end recording number 3. Thanks. Bye-bye.